Dinosaurs once roamed the ancient mudflats of the Connecticut River Valley. State lawmakers told 22 News State House reporter Christine Lee.
Thursday, July 10th, I'm Jordan Jagalinzer. Flash flooding is having a huge impact on some major roads this morning.
Massachusetts, a state renowned for its revolutionary history and cutting-edge academia's rolling hills, and the wild Atlantic coastline, lies a deep, often unexpected natural and human history. From fossilized forests, lost beneath coastal waters, to enigmatic ceremonial landscapes built by indigenous peoples, Massachusetts stands as a crucible of astonishing and at times unsettling discoveries. Over centuries, relentless curiosity has coaxed secrets from the earth, rivers, and sea, exposing a complex tapestry of geology, biology, and human endeavor. Each revelation, whether unearthed in a quarry, forest, or beneath surging tides, adds new layers to the ever-growing saga of this storied state. What stories do fossilized trees, meteorite fragments, and mysterious masses of warm rock tell us about the ancient forces that have shaped Massachusetts? Why do prehistoric footprints and long-lost shipwrecks continue to whisper tales of vanished worlds? Today, we embark on a journey through 20 remarkable, occasionally harrowing discoveries, each a window into the enigmatic natural and cultural heritage of Massachusetts. As we explore these uncanny findings, ask yourself, what truths still slumber beneath the fields, mountains, and waters of the Bay State, waiting for the next determined mind to bring them into the light? Join us as we unlock 20 of the most captivating scientific revelations in Massachusetts. Are you prepared to question what you thought you knew? Fossilized forests beneath the coastal waters. Deep beneath the waves off Massachusetts' coast, scientists have discovered a remarkable phenomenon: submerged remains of ancient forests, now entombed under layers of sediment and brackish water. These fossilized woodlands, dating from the end of the last ice age, form a chronology of ecosystems predating recorded human history. Why do such forests rest beneath the ocean? The answer lies in a saga of glacial advances, cataclysmic sea level change, and geological transformation. Thousands of years ago, during the peak of the Ice Age, massive glaciers locked up so much water that global sea levels dropped dramatically by more than 350 feet. Forests then flourished on what is now the ocean floor. When the climate warmed, glaciers melted and sea levels rose again. These woodlands were inundated, preserved under mud and salt water. Today, divers and researchers have recovered core samples containing trunks, roots, and even fossilized leaves. These discoveries allow scientists to reconstruct past ecosystems and to track ancient shifts in climate and vegetation. Each sunken log is a silent witness to the Earth's ever-shifting face, and a reminder that the coastline as we know it is comparatively new. Ancient indigenous ceremonial landscapes. Above the forests and on the wind-swept hills of Massachusetts, careful observation has uncovered complex patterns of stone and earth, ceremonial landscapes designed by indigenous peoples thousands of years before European settlers arrived. These sites are not merely relics, but testaments to the skills and cultural depth of the state's earliest inhabitants. Arranged stones, low mounds, and linear alignments suggest purposes beyond mere utility, possibly astronomical observation or ceremonial use. Some researchers speculate, based on alignments with celestial events, that these sites functioned as rudimentary calendars or markers for important times of year. Others see evidence of social or spiritual activities whose full meanings remain hidden. Whatever the intention, these sites reveal sophisticated design and a nuanced relationship with the landscape. As researchers use archaeological and survey techniques to better understand these places, The complexity of early cultures in Massachusetts becomes ever more apparent. What rituals unfolded among these stones? What knowledge was passed from one generation to the next in these carefully arranged spaces? Submerged shipwrecks and maritime mysteries. The floor of the Atlantic off Massachusetts is littered with the remnants of shipwrecks spanning centuries. These lost vessels, some dating from colonial times, serve as watery time capsules, revealing everything from trade patterns to personal tragedies. Marine archaeologists employ remote cameras, sonar, and careful dives to document these sites. Storms, reefs, and the unpredictable Atlantic weather have always taken a heavy toll on seafarers. Merchant ships, fishing vessels, and immigrant transports have all met their end on these hazardous coasts. Sometimes, personal effects and cargoes surface, telling fragmentary tales of innovation, trade, and tragedy. Beyond the remains themselves, these wrecks spark enduring curiosity and speculation about their lost crews and the events leading to their demise. Each is a microcosm of larger stories about human resilience and the perils of navigating one of North America's harshest coastlines. Dinosaur footprints along the Bay State's rivers. In ancient riverbanks and sedimentary deposits across Massachusetts, quarry workers and hikers have discovered layers marked with the distinct imprints of dinosaurs. These fossilized trackways, preserved for millions of years, are found especially in certain valleys and quarries in the Connecticut River region. The footprints range from three-toed impressions of meat-eating theropods to larger, more rounded tracks of herbivores. Arrangement and spacing provide clues about dinosaur movement, behaviors, and sometimes even social dynamics. Despite Massachusetts' relatively skimpy dinosaur bone record, its footprints are among the best documented forms of evidence that these creatures once roamed the region. Each print, preserved in stone, is an invitation to envision an ancient world of predators and prey, migration and struggle. What other scenes from this Mesozoic drama remain hidden, awaiting discovery? Discovery of fossilized invertebrates in quarries. Massachusetts's historic quarries have long provided building stone, but they have also yielded treasure troves for paleontology. Geologists working these sites have found impressively well-preserved fossilized invertebrates, ancient plants, insects, ostracods, tiny crustaceans, and decapods, ancestors of modern crabs and shrimp. These fossils provide unique windows into prehistoric marshes, lakes, and swamps. Insects fossilized in stone show unexpected detail, delicate wings and legs, often preserved with remarkable clarity. Ostracods and decapods reveal that long before the age of the dinosaur, rich aquatic life thrived in ancient Massachusetts. These discoveries allow scientists to reconstruct past environments in detail, painting a portrait of a vibrant, often alien landscape. What further biological wonders await beneath the next layer, quarried in the name of progress? Unraveling the mystery of the subterranean warm rock mass. Beneath parts of Massachusetts, New Hampshire, and Vermont, scientists using geophysical analysis have detected a vast mass of warm rock, spanning several hundred square miles and slowly rising through the crust. While not hot enough to be an imminent threat or classified as an active mantle plume, this anomaly puzzles geologists. This upwelling of warmer rock may have originated from ancient tectonic activity or the slow waking of geologic forces that have slumbered since the breakup of supercontinents. Its heat has a subtle but measurable impact on the thermal profile of the region, but there is no evidence of volcanic danger on the horizon. Researchers continue to monitor the area in hopes of understanding the deep processes shaping New England's geology. Does this buried giant hold further secrets about the forces deforming the very roots of the continent? Meteorites, visitors from the cosmos. Occasionally, Massachusetts is struck not just by terrestrial phenomena, but by messengers from the cosmos, meteorites. These space rocks crash through the atmosphere and onto the state's farmland, forests, and even town squares. Fragments recovered from such falls often contain minerals older than Earth itself, offering a direct link to the formation of the solar system. While most meteorites found in Massachusetts are small, each is carefully cataloged for study. These meteorites have generated local fascination and, sometimes, wild speculation about the universe's mysteries. Every recovered fragment is a reminder of the ceaseless movement and occasional violence beyond our planet's protective atmosphere. How many more such emissaries will find their resting place in the soils of Massachusetts? Ice Age glaciation and catastrophic sea level change. The features of modern Massachusetts owe much to the massive glaciers that repeatedly advanced and retreated during the Pleistocene Ice Age. As global temperatures plummeted, huge ice sheets bulldozed the land, carving valleys and depositing erratics, large boulders far from their places of origin. With sea levels locked in ice, land bridges and vast plains extended where ocean now lies. When the climate abruptly warmed and the glaciers melted, sea levels surged by as much as 350 feet. Coastlines, lakes, and even the courses of rivers changed almost overnight. In geological terms, today's Kettle lakes, moraines, and sandy outwash plains are the legacy of these cycles. By studying these glacial features, scientists reconstruct the sequence of massive environmental change that shaped the region and understand how rapid change can rewrite the world as we know it. Massachusetts's dinosaur fossils, echoes from the Mesozoic. Although actual dinosaur bones are rare in Massachusetts, fossil discoveries, including bones and teeth, have sporadically emerged from the state's ancient sedimentary rocks. Most of these finds date from the Jurassic and reveal a variety of prehistoric life that once inhabited the region. These bones, though sometimes fragmentary, offer invaluable glimpses of the ancient animals that walked the Bay State's land: predatory carnivores, plant-eating giants, and the smaller creatures of the Mesozoic world. Every fossil discovery, however slight, adds new details to scientists' picture of ancient life and environmental conditions. There are still many questions. What species are yet to be discovered? What was the interplay between changing environments and the evolution of these long-vanished animals? Analysis of ancient plant fossils, the dawn of Plantalogy. Massachusetts's fossil record preserves not just animal life, but also the remains of ancient plant ecosystems. Fossilized trunks, leaves, and spores from ferns, horsetails, seed ferns, and other early plants are occasionally found in sedimentary rocks, particularly near ancient lake beds and swamps. By comparing these fossil plants with their modern relatives, paleobotanists reconstruct ancient climates and track the fluctuations in atmospheric chemistry over millions of years. Some specimens even preserve microscopic detail, allowing for studies of reproduction and adaptation to seasonal shifts. These botanical time capsules help scientists piece together stories of mass extinction, resilience, and the gradual greening of landscapes that is essential to Earth's history. The enigmatic quarrying fossils, insects, and ostracods. Quarrying has not only furnished building materials, but also brought hidden fossil treasures to light, especially exceptionally well-preserved insects and tiny ostracods. In the deep beds of historic quarries across Massachusetts, scientists have found dragonfly wings and beetle shells, their microscopic features captured in shale and siltstone. Ostracods, with their distinctive two-valve shells, document the presence of ancient ponds and lakes and provide critical clues about the chemical conditions prevailing in those times. These tiny remains fill in vital details about the region's ecosystems, food webs, and climate. Every new insect or ostracod fossil helps to complete a grand mosaic of life, evidence of complex, thriving communities long before modern humans set foot in New England. Earthquakes in an unexpected land. Massachusetts is often considered geologically stable, But seismic activity, while less dramatic than in earthquake-prone regions elsewhere, does occur. Historical records and modern monitoring reveal occasional tremors, most of them minor, which sometimes rattle buildings or unsettle residents. Scientists track this activity through a network of seismographs, mapping ancient fault lines and studying the deeper roots of the region's bedrock. While the connection between the subterranean warm rock and earthquake activity is not direct, both are reminders that the earth beneath Massachusetts is shaped by complex, ongoing geological processes. How might these forces awaken in the future? Lake Enigmas, the formation of Kettle Lakes. Across the Massachusetts landscape, Kettle Lakes dot valleys and lowlands, each a remnant of glacial retreat. These lakes formed when blocks of ice, left stranded by withdrawing glaciers, melted and collapsed the land surface, creating depressions that filled with water. Besides offering scenic recreation, Kettle Lakes preserve unique histories within their sediments. Cord samples reveal pollen, charcoal, and algae dating back thousands of years, allowing scientists to reconstruct episodes of drought, fire, or ecosystem change. These lakes are also biodiversity hotspots, providing habitats for specialized aquatic and wetland species. What further paleo-environmental secrets are concealed in these tranquil oases? The return of extinct species, fossil evidence of lost mammals. Massachusetts' fossil record has revealed the presence not only of long-vanished reptiles and plants, but also of extinct mammals. Bones unearthed in riverbanks, old quarries, and coastal deposits attest to a prehistoric past when the landscape was traversed by mastodon-like creatures and other forms no longer seen in the region. Wear patterns on teeth and bones, as well as the stratigraphic context of their burial, allow scientists to deduce aspects of their diet, environment, and even ancient migration patterns, possibly in response to changing ice cover or drying climates. The disappearance of these species illustrates both the drama and routine of extinction as part of Earth's deep history. What other fossil bones still await discovery, ready to shift our perception of Massachusetts's ancient past? Archaeological discoveries of early settlements. Beyond the historic record of colonial settlement, archaeology in Massachusetts has traced habitation back thousands of years. Stone tools, pottery shards, hearths, and post holes document the everyday life of indigenous peoples who adapted to dramatic environmental change. These finds paint a picture of ingenuity, adaptation, and continuity across generations and climatic epochs. Trade networks, seasonal movements, and technological innovation all become visible through this material record. As more and more sites are excavated and analyzed, what new insights about native Massachusetts cultures are waiting to be revealed? Freshwater ecosystems and their hidden biodiversity. The lakes and rivers of Massachusetts are far more than scenic features. They are vibrant ecological networks teeming with aquatic life, some of which is ancient, rare, or even new to science. Stream surveys, habitat assessments, and long-term ecological studies have uncovered communities of fish, amphibians, and aquatic plants that illustrate both stability and rapid change in response to environmental pressures. Sediments in these waterways are rich in microfossils and pollen, enabling reconstructions of climate fluctuation, vegetation history, and water chemistry going back thousands of years. Today, species distributions are still being influenced by ancient glacial legacies, isolated populations, and evolved forms persisting where glacial waters receded. How can studies of current biodiversity inform our understanding of past and future changes? Plant fossil discoveries, ancient flora from beneath the state. Massachusetts's sedimentary rocks serve as a natural archive, preserving fossilized plants that flourished before and alongside the dinosaurs. Well-preserved leaves, wood fragments, and reproductive structures have been recovered from ancient riverbeds and shales across the state. These fossils reveal the shifting dominance of different plant groups, ancient ferns, conifers, and seed-bearing plants, each marking a stage in Earth's botanical evolution. Studying growth rings and cell structures allows paleobotanists to deduce seasonal changes, periods of drought, and responses to cataclysmic fires or volcanic eruptions. What dormant genetic secrets linger in the DNA of their living descendants? River corridors and the shaping of the land. Rivers have always been the great sculptors of the Massachusetts landscape. Glacial meltwater, catastrophic floods, and slow meandering flows have sculpted valleys, created terraces, and redistributed vast quantities of sediment. Geological surveys map evidence of old floodplains, ancient channels, and alluvial deposits left behind by major hydrological events. Such studies reveal the immense power of moving water, not only to erode and destroy, but also to build fertile soils and habitable new landforms. Today, with rainfall pattern changes and rising sea levels, Massachusetts's rivers may be entering another era of rapid transformation. Observing the legacy of past changes may be our best guide to the future. The impact of climate change. Lessons from the deep past. The geological and fossil record of Massachusetts is an extended cautionary tale and a guidebook. Ice cores, pollen samples, and tree rings all chronicle how the region's ecosystems have responded, sometimes with massive loss, sometimes with creative adaptation, to rapid swings in temperature, precipitation, and atmospheric composition. By comparing ancient episodes of warming and cooling, scientists can better understand the baselines and limits of resilience in modern species and landscapes. Which trees, animals, or ecosystems survived past crises? Which disappeared forever? These stories, written in stone and wood, offer critical lessons as Massachusetts and the world chart an uncertain climatic future. A land of endless questions and timeless wonders. Massachusetts, in all its rich and varied landscape, stands as an arena where immense natural forces and human civilizations have left lasting marks. Under forested hills and in bustling cities, beside tranquil lakes and the stormy Atlantic, the Bay State's deep history persists, sometimes in plain sight, sometimes buried or submerged, waiting to be recognized. For every fossil, shipwreck, or meteorite unearthed, 10 times more mysteries still slumber, waiting for discovery. What revelations yet to come will change our understanding of adaptation, survival, and transformation? Which stories, imprinted in stone, water, or artifact, will shape our future thinking and inspire the next generation of explorers? As scientists peer deeper into Massachusetts's layered past, one thing is clear: this land will continue offering questions, challenges, and marvels for centuries to come. What discovery fascinates you most? Fossilized forests, dinosaur footprints, or the tales of lost ships beneath the Atlantic? Share your questions and insights in the comments. What mysteries do you think still lie hidden, awaiting the next curious explorer? For more journeys into the wild realms of science and discovery, subscribe and stay tuned. Our next adventure awaits, a new chapter in the ongoing story of nature and humanity. Don't miss it.